Good day, everyone. This presentation examines how effective supply chain management can enhance lean manufacturing performance, using Toyota Motor Corporation as the case context. The study focuses on 4 key supply chain dimensions: supplier relationship management, inventory management, logistics management, and information sharing and technology. It explores how these interconnected areas can support waste reduction, quality improvement, smoother production flow, shorter lead times, and reliable delivery within a lean manufacturing environment. This presentation was prepared by Mohamed Salah and Arya Farghli and submitted to Dr. Dalia Yunus. This presentation is organized into 5 main sections. We begin with an introduction to the research problem and objectives. We then review the relevant literature, explain the research methodology, present the analysis and results, and conclude with a discussion of the findings, key conclusions, and practical recommendations. The study begins with an important manufacturing reality: lean production cannot perform effectively without a stable and responsive supply chain. Global competition requires manufacturers to deliver high quality at low cost and with greater speed. At the same time, supply disruptions can create shortages, delays, excess inventory, and production interruptions. This research therefore examines how key supply chain capabilities can strengthen lean manufacturing performance. The main purpose of this study is to examine how key supply chain management components influence lean manufacturing performance at Toyota. 4 objectives guide the research: assessing supplier relationship management, evaluating inventory management, measuring logistics management practices, and analyzing the role of information sharing and technology in supporting lean performance. The study has academic, managerial, and practical significance. Academically, it integrates several supply chain dimensions within one research framework. Managerially, it can help identify opportunities to strengthen supplier collaboration, optimize inventory, and improve information visibility. Practically, the framework provides structured recommendations that can support operational performance and continuous improvement. The central research problem is the tension between lean efficiency and supply chain uncertainty. Lean systems aim for low inventory, short lead times, synchronized production, and minimal waste. However, these advantages can also increase vulnerability when disruptions occur. The main research question therefore asks: to what extent do supply chain management components influence lean manufacturing performance? 5 hypotheses are proposed. The first 4 predict positive effects from supplier relationship management, inventory management, logistics management, and information sharing and technology on lean manufacturing performance. The 5th hypothesis examines their collective effect, testing whether these supply chain components together have a significant positive influence on lean manufacturing performance. The conceptual model presents 4 supply chain components as the independent variables: supplier relationship management, inventory management, logistics management, and information sharing and technology. Lean manufacturing performance is the dependent variable and is reflected through outcomes such as waste reduction, improved quality, smoother production flow, shorter lead times, and reliable delivery. For measurement purposes, each construct is clearly defined. Supplier relationship management reflects collaboration and coordination with suppliers. Inventory management concerns planning, control, and material availability. Logistics management focuses on transportation and delivery effectiveness. Information sharing and technology address timely, accurate, and digitally supported information. Lean manufacturing performance captures waste reduction, quality improvement, efficient flow, shorter lead times, and delivery reliability. It is important to recognize the scope and limitations of the study. The research focuses on the automotive manufacturing context and Toyota, using a quantitative framework to examine supply chain and lean variables. Most importantly, the statistical results presented here are based on an assumed or simulated dataset, until actual survey responses are collected. Therefore, the numerical findings should be interpreted as illustrative rather than as established empirical findings for Toyota. To summarize the introduction, the study is built around 5 key ideas. Manufacturing performance increasingly depends on supply chain capability. Disruptions can threaten lean operations. 4 major supply chain components are examined. These components are expected to influence lean outcomes. Finally, the integrated framework provides the foundation for the analysis presented in the following sections. We now move to the literature review, which establishes the theoretical and empirical foundation of the study. This section examines the definitions and components of the research variables, the principles of supply chain management and lean manufacturing performance, the relationships among the variables, and relevant models and previous studies. The research distinguishes clearly between the independent and dependent variables. The independent side consists of 4 supply chain dimensions: supplier relationships, inventory, logistics, and information sharing and technology. The dependent variable is lean manufacturing performance, assessed through waste reduction, quality, production flow, lead time, delivery performance, and continuous improvement. Supply chain management coordinates the flow of materials, information, and activities from sourcing through production and logistics to final customer delivery. In a lean environment, these activities must be closely synchronized. Effective coordination supports material availability, cost efficiency, information visibility, supplier reliability, timely delivery, and continuous production with minimum waste. Supplier relationship management refers to the systematic development and management of collaboration between an organization and its suppliers. Important elements include trust, communication, supplier development, quality management, joint problem solving, long-term relationships, and performance evaluation. Strong supplier relationships can improve material reliability, quality consistency, responsiveness, and overall lean manufacturing performance. Inventory management involves planning, controlling, and optimizing materials and products while avoiding unnecessary stock. From a lean perspective, the objective is to balance just-in-time efficiency with sufficient material availability. Effective inventory management reduces excess stock and the risk of stockouts, while helping ensure that the right materials are available at the right time and place to maintain stable production flow. Just-in-time inventory closely aligns material replenishment with actual production demand. Its potential benefits include lower inventory levels, reduced waste, faster response, and improved production flow. However, just-in-time systems also depend heavily on supplier reliability, accurate information, and effective contingency planning, because disruptions can quickly interrupt production when inventory buffers are limited. Logistics management connects suppliers, manufacturing plants, warehouses, and customers through the effective movement of materials and products. In lean manufacturing, logistics must deliver the right materials, in the right quantity, at the right time. Reliable logistics can reduce waiting, transportation delays, unnecessary handling, and lead time while supporting continuous production. Information sharing and digital technology strengthen visibility and coordination across the supply chain. Real-time information, integrated systems, tracking technologies, analytics, and digital dashboards can help managers respond more quickly to changing conditions. They also support better alignment among supply, inventory, logistics, and production decisions, reducing uncertainty and improving operational control. These 4 supply chain dimensions should not be viewed in isolation. Supplier relationships support quality and reliability. Inventory management supports availability and flow. Logistics ensures timely movement. Information sharing and technology connect the entire system. When these elements operate together, their combined contribution is expected to strengthen lean manufacturing performance. The integrated model links the four supply chain dimensions to operational stability and lean outcomes. The central logic is straightforward. Stronger supply chain capabilities improve coordination, reduce disruptions and waste, and create the conditions required for quality, continuous flow, responsiveness, and greater customer value. Previous models and studies provide support for examining these relationships. The literature generally identifies supplier collaboration, effective inventory control, logistics reliability, and information integration as important enablers of operational performance. This study combines these dimensions within a single Toyota-focused framework to examine their individual and collective influence on lean manufacturing performance. The literature review leads to an important conclusion: lean manufacturing should not be considered only as an internal factory system. Its performance also depends on external suppliers, inventory decisions, logistics reliability, and the quality of information flow. These insights provide the theoretical basis for the proposed research model and hypotheses. We now turn to the research methodology. This section explains how the study is designed to test the proposed relationships. It covers the research approach, target population and sample, unit of analysis, data collection process, measurement instrument, and the statistical procedures used to analyze the data. The study adopts a quantitative, cross-sectional, survey-based research design. The model examines the influence of four supply chain components on lean manufacturing performance. The unit of analysis is the individual professional respondent with relevant knowledge or experience in supply chain, procurement, production, logistics, manufacturing, or quality-related functions. The target population consists of professionals associated with relevant operational functions. The sampling approach is intended to capture respondents who understand supply chain and lean manufacturing practices. The final sample should provide enough observations to support reliability testing, correlation analysis, and multiple regression with an appropriate level of statistical confidence. Data collection follows a structured sequence. First, the required data are identified. Relevant respondents are then selected and the questionnaire is administered. After collection, responses are screened and cleaned before the dataset is prepared for analysis. Applying consistent procedures throughout this process is important for improving data quality and reducing avoidable bias. The questionnaire converts each research construct into measurable items, generally using a 5-point Likert scale. The items cover supplier relationship management, inventory management, logistics management, information sharing and technology, and lean manufacturing performance. Reliability and validity should be assessed before the hypotheses are tested to ensure that the measures are sufficiently consistent and appropriate. The analysis begins with data screening and descriptive statistics to understand the dataset. Reliability testing is then used to assess measurement consistency, followed by correlation analysis to examine relationships among the variables. Multiple regression is used to estimate the individual and collective effects of the independent variables on lean manufacturing performance. Finally, the findings are interpreted in relation to the proposed hypotheses. In summary, the methodology provides a structured path from the conceptual framework to statistical testing. However, because the current presentation uses assumed or simulated results, the same analytical process must later be applied to the actual collected survey data. Only then should final empirical conclusions about Toyota be made. We now move to the analysis and results section. The findings presented here are illustrative and include descriptive statistics, correlation analysis, multiple regression, and hypothesis testing. The section also extends the interpretation through SWOT and PESTEL analyses to connect the research findings with broader strategic and environmental considerations. The descriptive statistics summarize the central tendency of the study variables. In the illustrative dataset, the values indicate generally favorable assessments of supplier relationships, inventory management, logistics management, information and technology, and lean manufacturing performance. These descriptive results provide an initial overview before examining the relationships among the variables in greater detail. The correlation analysis indicates positive relationships between the supply chain dimensions and lean manufacturing performance in the illustrative dataset. This suggests that stronger supply chain practices are associated with stronger lean performance. However, correlation demonstrates association rather than causation. For this reason, regression analysis is used next to examine the relative contribution of each predictor while considering the other variables. The multiple regression model evaluates the combined explanatory contribution of the four supply chain components. The illustrative results suggest that the model explains a meaningful proportion of variation in lean manufacturing performance, and that the supply chain predictors contribute positively. These coefficients remain simulated and should not be interpreted as confirmed Toyota results until actual survey data are collected and analyzed. The hypothesis testing summary compares the statistical evidence with each proposed hypothesis. Within the illustrative analysis, the results are presented as supporting the proposed positive relationships. Nevertheless, final acceptance or rejection of each hypothesis must depend on actual collected data, validated measurement results, and the appropriate statistical significance levels. The SWOT analysis translates the research topic into a strategic perspective. Potential strengths include established lean practices and strong supply chain capabilities. A key weakness is possible vulnerability to disruption in highly synchronized operations. Opportunities include deeper digital integration and supplier collaboration, while threats include external shocks, supply uncertainty, and other disruptions that may affect operational continuity. The PESTEL analysis broadens the strategic perspective by examining political, economic, social, technological, environmental, and legal influences. These external forces can affect sourcing decisions, logistics, operating costs, technology adoption, sustainability requirements, and supply chain resilience. As a result, they can also influence the ability of supply chain management to support lean manufacturing performance. Bringing the statistical and strategic analyses together, the proposed framework suggests that effective supply chain management can support operational stability, continuous production flow, waste reduction, and stronger lean manufacturing performance. Once again, the numerical findings presented in this section are illustrative and must be confirmed using actual collected data before final empirical conclusions are drawn. The discussion interprets the results in relation to the conceptual framework and the literature reviewed earlier. The central message is that lean performance is strengthened when supplier relationships, inventory management, logistics, and information technology operate as one coordinated system rather than as separate functions. Integration across these areas can improve responsiveness, stability, and continuous improvement. The study concludes by identifying four critical enablers of lean manufacturing performance: strong supplier relationships, optimized inventory, reliable logistics, and integrated information and technology. Together, these capabilities can support higher quality, lower cost, shorter lead times, greater flexibility, and stronger customer value. This conclusion is based on the proposed framework and illustrative results and should not be treated as an established empirical finding for Toyota. Based on the framework, 6 practical recommendations are proposed. First, strengthen supplier integration and collaboration. Second, optimize inventory while maintaining sufficient resilience. Third, improve logistics visibility and reliability. Fourth, expand digital integration across the supply chain. Fifth, extend Kaizen and continuous improvement beyond internal operations. Finally, strengthen supply chain risk management. Together, these actions can support a more resilient, agile, and integrated lean system. The implementation plan organizes these recommendations over time. During the first 3 months, the focus should be on assessment and establishing baseline key performance indicators. From months 3 to 6, attention should shift to supplier development, inventory optimization, and logistics improvement. From 6 to 12 months, the priority becomes digital integration and cross-functional dashboards. Beyond 12 months, predictive analytics, resilience planning, and continuous Kaizen should be emphasized. Key indicators include on-time delivery, inventory accuracy, lead time, defect rate, waste, and overall equipment effectiveness. This data reference slide summarizes the intended evidence base for the research. It includes secondary sources such as Toyota reports, relevant industry publications, and academic literature, together with the study variables and performance indicators. Any illustrative figures used in the current presentation should ultimately be replaced or validated against actual primary data before final empirical conclusions are submitted. To conclude, this presentation has shown how supplier relationship management, inventory management, logistics management, and information sharing and technology can be integrated to support lean manufacturing performance. The framework emphasizes that effective lean performance depends on coordinated supply chain capabilities, not only internal production practices. Thank you for your attention. We welcome your questions and discussion regarding the framework, methodology, findings, and proposed recommendations.